Okay, once again, I'd like to welcome all of you to today's kickoff session kickoff as in the very first session that we have for the TikTok Tech Immersion program. And some general housekeeping rules that I'd like to share with everyone. So we're hosting this in a webinar format. So all of you, if you notice, are on mute. But if you would like to, interact with us, you'd like to share with us, you can use the chat box, chat function, like what some of you have done already. And then if you have any questions relating to this session, you can always plug them into the Q&A function below, and we'll come to those questions, whenever we have an interval. So Zijie, you're not required to create a facial account if you're just, accessing the materials. But yes, if you're going to join the chat group, which we will create later on, you do need to create a LAG account. All right. In view of time, I shall now invite our speaker for the day, Shijun. So Shijun is actually our engineering manager for the TikTok Global Live money platform team. So I will allow Shijun to introduce himself and also, share with you what he's going to bring to the table today. All right, over to you, Shijun.
All right, thanks, Motomi. Hi everyone. It's so excited to talk to all of you guys. In 3 days already 300 people join. I think last time I talked to that many people is in my wedding ceremony. A bit. Okay, so I think for today's session there are 2 sessions, right? One is the web server fundamental, and let's go along 101. I will be very excited to be the first speaker of the program to introduce you about the web server fundamental. It will last around 1 hour. We try to finish in 1 hour and leave 5 minutes in the end to ask some questions, probably 2 or 3 questions you guys may have. Then some people will ask, yes, we will have a break in the middle. Then my colleague will introduce the second sessions, right? So as Motomi just introduced, my name is Shijun. I'm the engineering manager of the money platform team. So yeah, from TikTok. So I am the engineering manager, and I has been working here for 3.5 years, almost 4 years. It's been quite a long time. I joined this company since only less than 30 engineers. I think 30 employees. Right now, there's thousands of employees already based here in our HQ in Singapore. So yeah, I will bring some more details about myself later, but Motomi, do you have anything to add before I start my sharing my slides?
No, I think I already briefed everyone. And I know several of you tried to reach out to Shijun earlier because Shijun is currently managing the money platform team. So naturally, he is also a hiring manager. So many people who are, are keen to join TikTok as an engineer, of course, wanted to connect with him. But bearing in mind the constraints that we have with today's time, please try to restrict your questions to those that are only related to the course today. We'll take any questions about recruitment, about internships offline, all right? So over to you, Shijun.
Yeah, I think there's many questions regarding us cannot access the material. We have a recording, and also if you cannot access to the material later after session, we'll figure out what's the problem and send all this material again via the email or other channels. So don't worry about it. Let me try to start this sharing first. Where's my? Just hold on. Where's my Chrome? Oh yes, yeah. You can see my sharing, right? It's on my side.
Yes.
So, okay, great. So this is about web server fundamentals. I know that this sounds like very basic things for you guys. If you are majoring in computer science, a lot of you has already learned from your courses. But so in this session, I will try to bring some different knowledges or experience from industries probably you didn't learn before, or probably it's I hope it's an exciting sessions for you guys. Yeah. But let me start myself first. This is a photo I took 4 years ago, 5 years ago before COVID, so still slim. My career actually started from 2009. I am actually a game programmer. At the time, I'm still in China. I'm a great game programmer working for 2K. I guess all the boys know about it. It's famous for the basketball game, NBA 2K. So I at the time I made the game. Then I came to Singapore, I think 2 years later. At the time that's no Grab, no Google. I mean, in Singapore, no Grab, no Google, no Meta, no TikTok, no Shopee. Yeah. I joined a startup company called Mozet. It's already a big company. We have around 100 people there. We are working for some instant message app for the Middle East users. It's a very exciting days. I worked there for 3 years. Working for startup is also always a very exciting journey. You have chance to a lot of things, but also you have very big responsibilities. You need to do a lot of works. You need to do SRE work, you need to do QA work by yourself. You also need to, coding. That's very exciting. Then I joined Grab back to 2015. That's very early stage. I still remember I joined the day they just opened it's the day they opened the Singapore office. So first batch joined here. I contribute the code to the booking system. I guess when right now using the Grab app to book a cab, probably still my code is still running there. So 3 years later, I joined Indeed. That's office closed, unfortunately. But I joined. I've been there 1.5 years. Then I came to TikTok to be a engineer. Then I was promoted engineer manager. I have been here for almost 4 years. So my team is called Money Platform Team. It's grown super rapidly. We have a company with the company growth, office growth here. So my team job is actually working platform to supporting all the, you can even name money relevant requests from different business teams. So for example, user want to subscribe some creators or subscribe be a member of the TikTok, or you purchase the coins, purchase the virtual gifts in the TikTok live, or we're serving the creators how we pay the money, their earnings out to our creators account, share the profit with them. Also taking care of the clearing settlement, tax, invoice, reconciliation, all these financial relevant stuffs. Yes, it's a very challenging things because we're serving so many users. We're around 24 hours. We have more than 1 billion users. Yeah. Just about myself. Okay. Yeah. Now let's start the session. So this is a typical web application architecture. I guess you probably learned it from your textbook. Yes, it's a good one. You see, we have fundamental things. We have load balancer to receive requests. We'll have web server to processing the requests. You write your business logics, and we have a database to store all these informations, data, persistent. Yes, it's a good one. It's good to do some small businesses, and also it's good for your school projects. Yeah, but in the I think now it's with the web technology has developed for more than 10 years. Beyond that, especially we have 1,000 engineers in TikTok. There must be a lot of things we need to do, right? So this is the more advanced architectures. It's not the one that we're actually using in TikTok. It's no, I cannot share the architecture with you guys, right? But it's a more complex one. I'd like to introduce starting from here. So you will see that from the fundamental ones, we have DNS, load balancer, right? Web servers, front end server to rendering the this front end fancy UIs, backend. You can see we have different backend servers processing different logics. Probably it's IO intensive logics or CPU intensive logics. We have a lot of microservices. cache, and yeah, we have cache to tuning performance. Database has different choices of database we have. And then we have some data warehousing, and more importantly, that we have data analysis, BI analysis. We have a dashboard to show the business metrics, sales metrics, and push notifications to the users to call them back to the app. So this is a more advanced one. I will cover some of the modules later in next slides. So you can compare it to the previous one where we have more. Actually, what we do more is we have we do more on the performance tuning, do more on the data analysis, and make the system be more robust. Beyond that, what else? It's in order to implement or build a proper large-scale system. You see, we have a lot of more components. Actually, we're building in daily life. But it's much more beyond that. But this is more typical or more generic one. Based on different business, I believe there must be a lot of different components are built. But this is the most general one. I think is necessary for a large-scale web app. First of all, is a account system, like it's do authentications, authorizations. Authentications verify who you are, right? And the authorizations say what kind of permission you have. Are you able to access access to the different levels of content, or you have view permissions, edit permissions. So this who you are, what kind of things you can do in the website. Payment system is my job, so let's start here. But not necessarily to have, but if you want to earn money, yeah, you need a proper payment system. It's a very complex one because you need to make sure that you don't have any loophole that you will lose the money or will be attacked by some people who will steal the money from your account. So for a payment system, more important is the stable and the consistency of your data and the service. A logging and tracing system, usually we're talking them together because that's how we make the system stable. So log, probably you also write some logs in your code as well, right? So it's from the very beginning, log is just system out printf some hey, hello world. There is a bug here. It's panic. It's not like this. So beyond the log, we are actually, first of all, in a real world, we don't use printf. We are recording down the logs into a normally we are using a lot of libraries. So the libraries will first of all recording down your logs into a local buffer, right? Writing a local buffer. Then asynchronously, this local data logs into local buffer will be asynchronously sending to a centralized logging system. Normally, it's a UDP. It's because some logs probably can be dropped. It's okay if we lose some logs, but we will send it to a centralized logging system. There are some popular open source one, for example, ELK. ELK stands for Elasticsearch, Logstash, and Kibana. So it's for persistency. Logstash is for the log tokenizations, and the Kibana is for the presentations to help you to have a virtualized way to processing all these logs. And also there's some enterprise products like Datadog. And in TikTok, we're building our own logging system. Actually, in TikTok, we have our own private cloud, building all these fundamental things by ourselves. Right? So we have a huge team to working on that. It's furthermore in the industry. So logging system, why are we talking logging system, tracing system together? It's because we are actually receiving, it's like millions of requests every second. It's huge. So if there is something happens, it's very hard to manually find the logs, and you have hundreds of microservices running, right? It's super hard to chaining each request. The request is hopping from one service to another, and then to another. Probably it's on all the way. There's 10, 20 services on a request journey. It's very hard to chaining them. So a tracing system help you to chain requests and chain these logs, and you can in a logging system easily find what's the entire life journey of a log looks like. They easily help you to debug. You know where the arrow is thrown and what's in each upstreaming services. How do they process it? Are they dropped or are they returned to the front end to the user? And also this tracing system, in a way, beside logs, we're also recording down the time cost in each services. So you will know that there's how much time is spent on different services, and you can tuning them. You know, if it's a slow request, you know what's going on in different services. You can try to find the problem. So it's a logging and tracing and configuration system is also a very important one. You know that in school project, probably you're writing a configuration into your local files, reading from files, or you're writing into a local DB. Right, it's good. Originally, was the storage behind configuration system is normally still a DB, a MySQL, whatever. But why we need to call it a configuration system rather than DB? The reason is, so when you are writing a code and you merge your code into your master branch, you release into the production. It's a very long journey, right? You need to do the test in a local, test with QA, test in the test staging environment. Then you have a CI/CD, you have a CI/CD all the way. Then you just release into production. You need to be verified very carefully. But config change, actually, it's equal to a code change. Imagine that you change a config. You're reading the config value from your config. You say, okay, right now the country is equal to SG, and some people accidentally just change the SG to US. Then some code actually then taking effect on US when nobody notice. It's a very dangerous thing. So config changes also need to be managed well. So a configuration system, one of job it is you need to have a way to manage all the config changes. You also need to have version control, have a approve system, and also have a rollback system, release system as well. So that's why we call it a configuration system. And also failover, if one of the DB is down, you need to make sure I have a backup for it, right? Okay, let me speed up. CMS, yes, API gateway zookeeper is also all the some business probably require on them. I need to highlight API gateway here. It's not quite popular. So API gateway is actually the first layer of the entire system that normally that you will do the things like accelerations, authentications, authorizations, and try to do the parameters verifications. If there's some decoupling, if there's some encryption decryption is also doing here as well. So there's a lot, you do a lot of general things. So when the request coming to the business logics business service, they don't need to do it again. Right. Okay. Let me see. There's any Q&A. No. Okay. Nothing. Yeah. Okay. Cool. Now let's looking back to this one. Let's experience a journey of a request coming. So it's a very typical. Actually, it's a very typical interview questions. Key in TikTok.com in browser. What happens? There's a lot of you can find a very detailed answer online, or you can ask ChatGPT, they will give you answer as well. So some answer very detailed is starting from I think it's starting from, so what's the hardware response? What's your keyboard doing? No, let's just from let's discuss a high level. The first step, we will talk about DNS. So see that DNS is the first step. What is DNS? I will cover later. So then it will try to establish HTTP connections. Actually TCP connections. Then you can send in the HTTP request over this TCP connection to the backend. The request will go to the load balancer, distribute to the backend service, and do some processing. If it's success, write to DB. If it's not success, we'll return some errors, running some error page. And then it will be shared. The data sometimes will be shared to this offline analytics. Just to normally there's some offline DB to processing it. We have a huge data team need to dealing with data analysis and provide this information to the decision makers. And then CDN is an important, interesting topic. It's a content delivery network. It's more like a cache. It will deliver some static content to you. It's very straightforward, but why? It's why it's like this, and it's important is because I just want to highlight. You will see that it's not only about writing code, writing business logic. In the middle of this picture, you see that we have some servers, right? But beyond that, there's quite a lot of different components is functioning here. It's not necessarily about their business logic, but it's very important to a large scale system. It's will help you to it's caring about efficiency. Either the efficiency means the system performance or the efficiency of your engineers development and stability. There's just like the logging and tracing system I just mentioned. It's about stability of the system, able to let you know what's wrong with the system and able to help you to detect the root cause and fix it. Scalability, to scale out when there's more requests coming, you have a way to scale out. And safety, account system help to guarantee it, and also we have firewalls and to help you to guarantee the safety of the system. And also dashboards, all these metrics help you to as well. It to let you know if it's some abnormal things happens, it will be reflected on the dashboard. So you will get alarms and take a look. And also, yes, offline, unless things help to generate the data to the decision makers, because right now we're trusting data, right? We want to make it be a data-driven decision making. So all these data will be collected and running to different batch of processings and providing different conclusions. So, right, okay, this is very fun. I guess you have learned it from your school already, or the DNS. So DNS is very important one as domain name system. Basically, just translate your domain name tiktok.com to an IP address. So this is a very essential part of internet infrastructure. So as a normal user, you don't have to remember all these IP address, and you just need to remember tiktok.com. That's it. And later on HTTP connections. It brings ideas. I guess you also learn as well. HTTP connections bring idea of a protocol. Actually, HTTP is a protocol, right? It's an application layer protocol. So we have a lot of different protocols that have been used in our real life. So what is protocol? Protocol is a computer, just like the language I'm saying. I'm speaking English right now. You can understand what I'm talking about because I speak in English grammar, in English vocabulary. I'm using the English alphabets, right? So this is a set of rules and guidelines that's govern the communication between network devices. So all network devices, just like all human peoples, they understand the same rules. So it decided how the data is transmitted and received over network. So why we using HTTPS? Because first of all, HTTPS actually it's a combination of two different protocols. One is HTTP, S stands for secure. Normally it's a TLS. So TLS is running on the layer. OSI network model is on layer 6. It's a presentation layer. HTTP is actually application layer protocol. Normally in public network, we are using its most popular one is HTTPS. Why? Because just like I just mentioned, that this is like a language. Everybody if you need to understand, communicate each other, they must know this language. So most of the devices in the world, no matter browsers, they by default, most of them they understand HTTPS. So if you are building an app, you want to have a broader user base, what kind of product you want to choose? Definitely HTTPS, because you don't need to worry about some devices don't know and don't understand your protocol. Right. And the browsers by default they natively support HTTPS. And inside if there's an intranet inside, for example, inside the TikTok, among these backend services, we are using Protobuf, we're using Protobuf. That's why, because it's a more high efficient one. The data is compressed, and the decoding, encoding and decoding is much faster than HTTPS. So in order, if you only have very few requests, it's only like they have 100 or 1,000 requests per day, then it doesn't matter, because performance is not the things you are worrying about. But in TikTok, we have millions requests per second. So even 1% difference is causing huge difference. So Protobuf is the choice that have much high performance, more efficient than HTTPS. We're also using JSON sometimes. And here's another interesting thing is LHV. It's stand for length head value. So this is the one that I'm using before even Protobuf is invented. At the time we don't have Protobuf, and what shall we do? If I want to have a high performance protocol, but this is the one I used before. It's like when you're building up a TCP connections, when you're starting listening on a pod and receiving the data on the network. It's a streaming of networks, a streaming of data. Right? It's not the data streaming is not split by packets. So length, normally we define it's a first, as we say, it's a rule. So length always be the first 4 bytes. Then you read the length, let's say the length is 100. The stand for the next 100 bytes it belongs to this packet. And the header probably is 8 bytes. Header normally define what type of the packet it is. And also there's some kind of other bits just indicate different meanings. Then the remaining 90 bytes that is the body. So then you read 100, then read another 4, and the next 4 bytes is the length again. So this is how it works. If you're directly reading from a TCP, then you need to define a way to how you read it. Actually, Protobuf, such kind of things, if you're looking into the low-level codes, it all works similarly like this. You have a way to split either a length, or you have a way to split different packets. Okay. Yeah. So load balancer is also a very important component. So before I introduce load balancer, just thinking about it, what if we don't have a load balancer? or what will happen? Right, if we don't have load balancer, it means each server need to export their IP address to the public. A client need to remember need to keep a list of the IP address. Yeah, then they can build a connection, set up a connection between client and one server. If the connection is broken or server is sunset, then he need to pick the next one from his list and build connection to the next server. And if it's a new server into cluster, he need to send a request, pulling the latest server list, right? And this is just for one server and one cluster. What if we have 100 different kind of clusters? So a client need to do this, keep a huge map and keep pulling. It will be a very waste of the resources and not efficiently. And the client cannot and the client don't know the server status. Probably some server is overloaded, some is not. So load balancers play a role like, okay, you just send me the request, I will distribute the request, the work to the backend servers. They have a lot of different strategies. The most typical is round robin, so evenly sending the requests to different servers, or this can be application you by some strategy, by some rules. For example, by the countries. So some particular server will handle US countries, some will handle Asia requests, or by user IDs. When we want to run some experiment, running some A/B test, so we will probably be adding some testing server, and only the user ID is within the experiment group will be sending over to this testing server, and probably this testing server is running a new code with some experiment code. So different logic base will be implementing load balance about just load distributing based on your own needs. Right. Okay, let me take a water.
So, Sujin,
yes.
I think there are a few open questions. One is about load balancer. Another one is from FEBE.
Okay, I think I just explained the load balancer here. I'm not sure if I answer the question. So if your FEBA based on request from FE based instead of push from B, so your FEB based on request from FE instead of, I'm not quite sure what the question means. Sorry, probably you can just add some more question below or with some concrete example. I'm able to document. Okay, no, I think that yeah. So for people who ask the FEB question, probably you can ask again with some concrete examples. I probably will answer it later. All right.
Yeah. Thank you.
So right, then is the CDN. CDN is an interesting thing. As I mentioned, it's okay, stand for content delivery network. So actually it's a cache. It's cache for static content. Why we need it? Because you can tell from the picture on the right side. The CDN, they have a lot of different data sites, or they have some different data centers. A building just close enough to our users. This, for example, it's not like a TikTok. Probably in TikTok we have several different data centers around the world, but it's less than 10. All right, we will have huge data centers. It's a centralized one. In each data center we have millions of servers, right? But CDN is right. They probably have hundreds, thousands of different small data sites, but they're just building close enough to the users. So as I mentioned, there's a cache. So in the backend, we'll push this stated content. For example, short videos, live streamings. Yes, live streaming you can also consider as static content, because probably it's actually is a several seconds delayed from the host, but all this content will be pushed to the CDN to store there. When a new user coming and start watching it, you will pulling it from CDN as well. And also group chat. Some kind of group chat also implemented by CDN also involved as well. And most typically, this photos, images. If you feel it's very slow to load in the photos, definitely this kind of website is not using the CDN. So all these static material contents are using CDN. So it's like backend will push the things to the CDN, and CDN, and when you try to use your terminal to dig the request, you will find them somewhere domain name on the path. Probably, for example, you dig some request sending to TikTok, you'll find some is not belong to TikTok, it's a different domain name. Probably it belongs to CDN, because we're also using some external CDN to help us to deliver the content. Why we need it? First reason, if it's close enough to the users, then definitely is provide better performance, and you can load in faster, right? And also improve the reliability. If you're loading this file, you can switch to the backup CDN, or you can directly reading from server, right? If the server even TikTok, the data center is down, CDN still keeps some content, so hopefully you still can reading from it. Yeah, it's why it's quite important and play a very important role in the modern system architecture. This is based on my personal opinion or experience. So for a web server fundamental, the first thing, functions. Yes, the very important things. You have app servers, you have different microservices, you have online DBs, you have caches. Yes, it provides the basic functions. If you are building a cab hairing app, yes, you need some app to building a booking system. You have a driver system, you have a payment system. Yes, all these things. You have e-commerce, yeah, you have catalog system, you have voucher, payment, user account. Yes, but beyond that, what else we should have, and we must have in a for such kind of system is offline analytics system. We collect all the user data. Yes, I think it's very popular. You know that in TikTok we have recommend different videos to you guys, right? Everyone have different user experience. How we achieve it? We collect your watch history, or we collect some location informations. I don't know. I'm not working on that one. But we collect different datas and the users' behaviors or whatever. You're probably using AI, using machine learning, or probably using some rule-based strategy to make the decisions. Also, we also will collect these data, provide some metrics, business metrics to PMs, to the decision makers. They know, or to operation teams, they know probably there's some decrease or increase in certain area, in certain regions, in certain products. They are trying to find the root cause and reason. So all these data, offline data, will help to provide us the clues to all these. Right? Then we can use it to improve our product, make it better. That's how we iterate. It's not like, okay, I have a good idea, let's do it. Yes, you can do it. If you have a good idea, you can try it to your own startup. But when we have a big team, huge team, we cannot rely on some single people's talent ideas. It's a more reliable way is we just gradually iterate our system based on the data, based on analytics. So we need to collect data. So this is the second part. The third part is stability. We have 1 billion users, right? If we have done for 1 hour, so immediately you will see it on the news. In tonight's news, TikTok went down for 1 hour or 2 hours. it's definitely where you will see it. You will Google it, you will find TikTok is down. So it's huge. It's very important that you make the system stable. Even if partially down, it's not entirely down. If it's partially down, for my team, it will affect the entire revenue. And for if say short video team, some people probably cannot visit the videos. For social messaging team, probably you cannot send the messages to the creators, to your friends. So it's very important to make it functioning work stably. And how we achieve it? So beyond on the top of the business logics, we need to have logs, metrics, tracing systems. We need to have plan for disaster recovery, have a plan for alerts and on-calls, a schedule for on-calls, with a SOP for the online incidents, and then we have postmortems for to review the online instance, have the action items to take. So it's a very complex. It's not only the coding. What I'm to try to say this, it's a system. It's a standard you need to follow to make sure that you have a way to make your system stable. This part of the DB and cache, I believe that there's I think this next few days there's another cache. We're deep diving into the DBs. I know it's my colleagues. He's a genius and he's an expert of DB. So I will not talk too much about DB. So I will just quickly brief it. So you all use the DB and you have learned that there are a lot of DBs, right? Different kind of DBs. You have MySQL, you have Cassandra, Edgebase, Elasticsearch, and also Graph DBs, Mongo. Yeah, a lot of things. So we are choosing DBs based on our own needs. So for example, that if you want to have transitions, definitely we'll think about MySQL, right? And if you want to have some search functions, if you start tons of data, you want to search some things from this kind of data, you will think of Elasticsearch. And if you need to have some eventual consistency, but you will still want very high availabilities. You want to see some NoSQL like Cassandra, and schema is free, right? And also GraphDB is provide some functions, help you to find the connections. I can give some example. For example, here in TikTok, in my team, previously working on some projects, detect some suspicious top up behavior. Then we will try to just suspend their account because they are probably doing some money laundering things, or they are doing some illegal things. So how we do that? We have all the users' transaction information, right? They purchase through our platform. We have all the user transaction informations, and also we have user data. So we try to leverage the GraphDB's capabilities, find the connection between these transactions, find the connection between these users and creators, and use the AI. Initially, it's not AI. Initially, it's a rule-based. Then we try to also build some models, train some models, use AI and machine learning, gradually use it to find these suspicious behaviors and suspend such kind of, or just stop such kind of transactions happens. So based on different business needs and requirements, you can choose different DB. A cache, also typical one. You will hear this, but there are several layers of cache. It can be from hardware. You have a hardware cache, you have CPU cache, layer 1, layer 2 caches. It's an important one. Help you to optimize, especially that for those performance sensitive products. CPU cache is also the things you probably want to turn in as well. OS cache, CPU cache, OS cache, and web server cache. It means a local cache. You have a map. You're building a hash map in your code, and reading and writing read from it. It can be also LRU, LFU, this kind of cache, application cache. That means Redis, memory cache, all these things. So it's a remote cache system you're reading it from. So cache is important thing is balance the needs for speed and efficiency, and consistency and accuracy. So cache always have as a problem. It's very hard to solve as the cache expiry. When you should expire the cache, when you should read the latest data. This is the problem. There's no standard answer for it. It's always based on your needs and requirements. And it's always troubles engineers a lot. Even now it troubles me as well. So it's a thing that you need to carefully thinking about. Forget to expire cache will be a very hard thing to debug, and very it will trouble your problem, your product a lot. I don't have an answer here. I just leave it as, but I will tell you. Do you remember cache expiry is very important thing and very hard things you need to design it.
Sorry, Sichuan, is it okay for me to interrupt?
Yes.
I see a couple of questions under Q&A and also 2 in the chat box. Maybe you want to take them for a bit.
Okay. Okay. Probably I will real quick. Is the load balancer that's the same as large storage of all IP address, and it's relevant to US? Is the load balancer the same as large storage of all IP address? No. Load balancer is not a thing like this. They play different roles. DNS sometimes also plays a role. As a load balancer it can be, but DNS also have a problem of the cache things, and so and the performance you cannot for a large scale system. You definitely don't want to use DNS for a load balancer. There's a lot of it's already a lot of product you can find online. You just search around. Is a load balancer like a multiplexer? No, it's just distributing requests. Plainly, it's just distributing requests to the backend. It's not just one-way distributing, right? When you reply the request, it will have a separate forward proxy to the front end. So it's a very complex thing. It depends how you're sending. Sometimes you would like push notification. Sometimes you would have build a separate connection with the client. So it cannot simply say the load balancer play a role as multiplexer or not. You mentioned that the live static content. Does that mean that when the follower who send the gift to creators, the creators are added on top of static content? Or no. I mean that's only the content that's sending out. It can be a static content. Only the content that they're streaming is a static content. But when sending gift, this is definitely a separate logic directly hitting our data centers. It can be HTTP request. Or if you're using a mobile, it can be our own connection, overall own connection, or basically over TCP. But only those non-interactions request a response. It goes through the CDN. Why would a data center warehouse be to be good in TikTok use cases, especially since they largely store unstructured data? Would that make more sense? Yes, I just gave an example here. Data warehouse, data lake, we use them all. As I say, we have quite a lot of different needs. It's not like a single solution can solve all the different requirements we have. We do have such kind of requirements, both warehouse requirements and lake requirements. When consider requests, you mentioned the HTTP when using the data affect the secure side of HTTPS. When does it affect the secure side of HTTPS? No, definitely not. So I think probably this is okay. Oh, I haven't answered it, but as I just mentioned, quickly answered for that. Protobuf is layer 7. It's application layer, and for secured if we're talking about security, secure TLS is on the layer 6. So definitely protocol can on the top of the TLS. So this is another problem. How do you ensure that DDoS attacks do not happen on TikTok and this happens to a significant issue talked about when the communication systems? So as I mentioned, I don't go through details, but there's a firewall. I guess SI team is where they be an expert more than me. So they will introduce it, I guess. So they are definitely the first, there is a firewall in the system, help you to block all these DDoS, either hardware firewall or we have software firewall as well. This is the 4 things I can do. I guess I should stop here. For I think there's a lot of things.
Sure, I think we can continue later on.
Yeah.
Thank you.
So OLAP. So I just introduced the DBs. I guess there's a lot of online transaction processing. You guys familiar with the online analytical processing is using for data analysis and reporting. This example I just mentioned, right? The situation case. Another example can given from my experience on my team is we know that there's a local risk control team. So how they control risk. Again, this must be a real-time thing. So we receive a request, we send it over to the risk control team. What they will do some analysis. They were comparing this request according to a rule, their policy, to the training models, and all these rules, policy, training models behind them are the huge of data. So they were processing, they were just sending this incoming request and analysis it, sending to process. So it doesn't require any transaction, right? You don't need to expect a MySQL transactions take place, but it needs to have some analysis framework running on it. So we have some online analytical processing service as well. And also they're doing some reporting as well. Yes. Okay, this is my favorite part. Metrics, alerts, logs. This is the third part models I just mentioned, stability. So actually stability is the quite important things because when we are doing the tech review, tech designs, when I review the tech designs, so this is the important part I always spend most efforts on, because I believe this business logics will have very comprehensive product requirements to describe what kind of business logic we want to implement, and also this logic runs wrong. We have a QA to test. We have a lot of ways help to verify it. But all these metrics, whether we have proper metrics, whether we have good enough alerts to help you find the detected problems, and we have good enough logs to get the root cause. Yes, the things we must very carefully design in the system design phase. And normally people don't have too much experience on it, and because they don't, some people don't experience too much accident, they not pay attention to it. But actually, it is, at least in TikTok, I guess also in many good company, big company as well, this kind of things, design these kind of things, implement these kind of things, and getting information for these are the most important part, or not most, probably very important part of the engineer's day-to-day life. I think you should expect 20% at least in your day-to-day life to dealing with these kind of things, and designing or reading them, accessing to them. So just take an example. So for example, you need, if there's errors happens, right? For example, we have some downstream service. We're talking to the banks, right? To tell the banks and call their API to deduct money or make some transactions, pay the money out. So if the bank keep returning the error, we have they will return error code to us. Then we must log this error codes, right? After logging these errors, what should we do? We cannot wait someone just happen to check the log of they say, 2 days later, we find some problems. Then we must have an alert system. When this logs count has exceeded some threshold, then they will send alert out to the team, to the engineer team or other operation team, SI team. Let them know something goes wrong via some via blog, WhatsApp, call your phones. First something goes wrong, and the log will be grouped into a logging system. Engineer logging to see what's the problem, see the error code, and what's the consequence. Log only tell you things go wrong. What's the consequence? Then all these metrics will tell you. You also need to design these metrics carefully. Okay, if this bank keep written errors, means keep failing. We need to record on it. We know how many failures is happening, how much amount of monies we fail to make the transition. Then we know that then how much money we probably lose due to this failure. That was the consequence. And the metrics will tell you as well. And also there's a business metrics. System metrics will also tell you CPU is crazily increasing. Probably you can find some problem from it as well. And we also set some alert on these metrics as well. For example, comparing to last week, same day last week, your success rate, payment success rate, 10% off. Your transaction amount, 5% off. Then we'll send alert out. Probably not to engineers, probably to the PM. Right? They will need to check it out. What's going on. Probably it's not because of the system problem, because in this region, it's their payday, or this holiday. Or there's a campaign last week. The campaign is over in this week. So we just cause such kind of difference. But we need to know the reason of any abnormal things happen in the system, and have a way to answer it, to investigate it. It's super important for a large scale system like TikTok. There's another things we call disaster recovery. So there's one kind of example that's called active replications. It's very straightforward. You see there's a mirror left and right at the same. That means that in this replication strategy that we are distributed our load to 2 different data centers. They may be physically apart from each other, probably thousands of miles apart from each other. So let's make sure that why we need to do that? Because it may happen if data center is down, it still happens. For example, the air conditioner is not working. If the air conditioner is not working, then your CPU temperature goes high, then it will burn and probably cause the entire DC to goes down, and your service stop running. So entire DC also can be done. So we have 2 separate DC physically running separately in different places. Then make sure that one is down, another is up, but still got some problems. All right. One problem is cost of maintenance, because you have 2 different DCs, you need to maintain cost. When you just update one DC, you upgrade one DC, then you need to make sure both of them are upgrading at the same time. Otherwise, they're probably a different logic running different DC. This is probably something you don't want to see. Right? Cost of servers, you see a double of servers running, increase your equipment cost, and the consistency of data. If there's some data, probably will be for example, transaction, bank transaction. A very straightforward example is bank transaction. You're reading from bank, you read the account, you check the balance, make transactions, write to another account. This is several steps. Then you need to make sure the data is consistent. If if the traffic is randomly distributed, right? So you need to make sure the traffic is the data writing your DB is consistent to each other. Otherwise, probably one DB will overwrite the one you just updated in another DC. So this is one kind of strategy of the disaster replications. Another one is remote standby. So we also have another two DCs physically in different places. But in the standby DC, you see that all these are transparent here. It means we have minimum, we just spin up, have a minimum instance as be ready there. It's not running. Only the DB is actually running and keep getting the data from the master DC. But once the master is not functioning, then we are scaling out the standby DC and make it be master. Then because the data already replicated from the main DB, the primary DB, so we make sure that we also get some data, yes, and make sure that we are still can running if the primary is done, but still have some problem, right? First of all, is the scaling out take time. It's not that happens in minutes. It can take several minutes to scan out. Again, you have a maintenance cost. You also need to, when you upgrade, you also need to make sure that both of the classes are getting upgraded. Otherwise, if you are unfortunately have to switch to the standby DC, then you will find you're using outdated data, and it will even cause big trouble. And also the data loops, because even you keep copying the data over from the primary DC, but the time when it's done, probably some request is processing in the middle. You are not always getting the latest snapshot from the primary, right? That's also a problem where you're facing. But in computer science, in web design, there's always trade-off. There are no perfect solution. Cache, DB, there's disaster recovery logic, even using log, whether we're using log, how many log we're using, they always trade off. Because log, people may ask why log is trade off. To my personal experience, there's like we see a lot of accidents or CPU spike due to log. Some engineers just don't write a proper code. They have a for loop, keep writing a log. But actually, log is an I/O operation. It may cause you may use a lot of CPU. So all these things, all the decisions are trade-off. You just need to find the best solution for your service, for your product, right? Yeah, perfect. I think that's all I'd like to share.